Tēnā koutou, anō everyone. Welcome to MOTAT. I am your MC for this evening. My name's Lorenzi Benet. We are excited to be taking off with our next series of Ngā Kōrero Rererangi, Aviation Conversations, right here in our beautiful aviation hall. We're celebrating Aotearoa and Pacific aviation technology from the past, the present, and the future. Now, let's return our focus to why you're all here tonight. Thank you so much for coming. Winners of Māori Company of the Year in New Zealand High Tech Awards in 2024, Envico began from very humble beginnings with two Kiwi innovators, Cameron Baker and Samuel Vai, developing drone technologies in their Auckland garage in New Zealand. Their innovation focus and Māori values, including kaitiakitanga, underpin how they approach their work. We are thrilled for the opportunity to hear about their story tonight as part of our Matariki program for 2025. If you think of any questions throughout this presentation, we do have QR codes on the back of the seats there, which will take you to a live audience Q&A. Please post your questions there and we'll have an opportunity to visit those at the end. Now, can I please ask you all to put your hands together to welcome Cameron Baker to the stage.
Thank you everybody for making the time, and thank you very much for the warm introduction. It's always a pleasant opportunity for me to share the passion and the work that we do around New Zealand and around the world. And on something that I'm very passionate about, which is conservation and innovating technology within a space that has been probably dormant for the past 60 odd years. So tonight I'm going to give you a bit of a history of our company, how we started from that very small garage, and how we operate today, and what we look to operate, or how we look to operate in the future. So yeah, thank you again for the warm welcome, and any questions, feel free to fire away. I want this to be an opportunity to answer anything around the drone conservation space, our journey and how we got here as well, so don't be shy. In the later part of 2019, myself and my business partner started a company called Envico Technologies. At the time, we were working with drones and doing all sorts of different work with drones, from power line surveys in 2019 to aerial spraying. We were doing fertilizer, we were doing native seed dispersion, everything you could possibly think of with different systems we were doing before we started our company. But it was very early stage drone adoption back then. We were still compared with helicopters and taking jobs at that stage, and things like that, where I think the understanding now has been how do those tools enable helicopter businesses to take on more opportunities. So in the very early days when we started our company, we got the opportunity to take this very drone here and another one off to the Galapagos Islands, and we did the world's first ever drone eradication project, dropping bait, which was successful. We claimed success after 2 years. So after 2 years of monitoring, we successfully eradicated rats on 2 islands in the Galapagos, which began our journey as a business. We got a lot of opportunity with the media to explain how we got here and what we look to do in the future then. And we brought all of that technology and that publicity back to New Zealand and started our company and looked to do everything else in between, because when we finished in the Galapagos on San Norte, we patted ourselves on the back and thought, awesome, well done, that's it, job done. And then you see everybody else continue working for the next 2 years and enable communities to be able to take that project on themselves. So our focus then shifted from patting ourselves on the back, thinking we did a great job, to developing new technology to help enable more projects, more communities, which was the genesis of our company now. The reason why we felt the need to continue to stay in conservation, to continue to innovate, was because of these stats here. 1 million animals and plants at risk of becoming extinct by 2050, 60% of the threats caused by invasive species, and half of the global GDP dependent on nature. So when you start saying, okay, I've done one job, I've done one island, and we're successful, what does this look like on a global scale? And you start to see those stats. you start thinking, is the technology that I've developed or is the technology that's currently available up to scratch to be able to hit those targets? And no, it's not. We're not saying that we're going to take away jobs from other aviators or other conservationists. We're looking to enable our opportunity to make sure that that number is never hit. We started looking at islands. One of the first jobs that we did was on islands of the Galapagos, and working with a partner, Island Conservation, who also focus on islands. We enabled them to help change this. So 41% of the world's threatened species are found on islands, and one of the biggest risks to threatened species is rats. So we looked at using drones to eradicate rats on islands, and looked at lowering the cost and enabling more islands to be done with the same amount of money. Here's just a brief example of what eradication truly looks like as an opportunity. This is taken from one of our partners, Island Conservation, in an island in Chile, where goats were present before, and 2 years after, when you can claim eradication, that's what it looks like after. It was goats versus the rabbits. So once the rabbits were taken off that island, not only did the flora and fauna come back, but you also saw less erosion coming from that landscape as well. So not only just managing that problem, but eradicating that problem allows that to come back naturally. Bear in mind, if there's nothing there, typically there's no birds. If there's no birds, there's nothing spreading around those seeds. So that's just all of the natural regeneration from not even helping that, and we'll get into that later. So that was our past, looking together now with our now. What are we doing now in the scope of drones and innovation within conservation? This is where we're at. This is what we're capable of doing now. And a bit about the scale of what we're achieving with small drones and large drones as well. So the first step of what we do when we look at our now is we quantify the problem. So before, when we looked at doing different innovative technologies, we thought about dropping bait, but there's a step before this, is quantifying what your actual problem is. And when we started to dig into it, it's scat surveys, it's on small blocks, deciding where and when bait is going to be dropped. And when you start looking at the public narrative of, specifically in New Zealand, around the use of 1080, and your justification is a 10 metre square block of scat that somebody's seen to determine whether that block gets 1080'd or not, questions start being asked, and fairly so. And so we came at the problem not from either side. We were innovators, so we weren't coming at it from a conservation side, we weren't coming at it from a deer hunter's perspective either. We just thought what was fair and what gets to determine what gets done, and how do you use data responsibly to determine from both sides what the right option is. And so our first look after we did aerial baiting by drones was to use drones as a platform to carry a different payload. And so this payload here is using the thermal drone that we actually have on display here at MOTAT. And what it's doing is we're looking to advance the detection rate of possums here in New Zealand, with this example, compared to traditional means. So traditional means here in New Zealand is a 33% detection rate using a leg hold trap, which is like a little noose around the leg, where an animal comes up and feeds on some flower on a tree and gets its leg stuck. So they have a 1 in 3 chance of hitting that trap, and that being the determination of whether there's population density there or not. So we took a different approach. We thought, how do we not disturb the animals? How do we let them operate in their own habitat, how they would naturally, without any disturbance, but collect the data on them, and how do we compare that so that there's a direct correlation with traditional means, so that we have a starting point, and we are able then to quantify what our results were using a thermal camera attached to a drone. So in our early days, we started with the very small thermal drone. If you get the chance to see it, it's probably the most rugged thing you can see in this whole display, but it's been through the walls. It's been all over the country, all different temperatures. It's seen, it's processed for us captured hundreds of thousands of images of possums for us to build our library of our thermal detection model, which enables this. So what we can see here is the flight plan of the thermal drone. It's going over a tried and true method of wax tags and chew cards along those green ticks. So those are traditional capture kind of markers to quantify if there's animals there or not. And then we've flown over that same area with our drone, and every area that you see that's not blue is a detection of animal, a possum, that has been in that area or has moved from one area to the other. And where it's bred, and in this block as an example, we found 27 different detections of individual possums. Those green dots there picked up one. So in different areas, different vegetation types, different weather conditions, it's all going to change. But this was just the start to say that there's something there, and the innovation that we were developing was a step change in what the current technology was. So we did a program with Osprey, and I'll show you a video after this. We did a program with Osprey and Predator Free 2050 where we used the drone to detect possums that we knew were possums. So we caged them first, then we put them in leg hole traps. We went out to the wild. We didn't do collared animals, but we got enough data from that to detect a possum different to a cat and a possum different to a rat. And if we could detect a possum out of all of that, we could detect the other animals, deer, pig, goats, tar. So that's why we focused on possums to start with. And we did many tests, but the intent was, can you build the model? Can we automate that system? Can we go from 100 hectares a night to, it was 5,000 hectares in a week? And the answer to that is yes.
Yeah, it's always easy.
It's always yes. Here's a brief video of a possum. So what you're going to see is hot spots, and in a bounding box of a hot spot, and it's going to show the percentage of what it thinks, how high of confidence it thinks that is a possum over anything else. So if we get enough angles on it, and we're talking minimal pixels in a hot spot, if we get enough angles on it, based on our library and everything else that it's seen, we're determining whether that's a possum or not. So that's a possum sitting in a tree. There's a bounding box around it, and next to that, if I didn't enlarge the picture so high, you'd see a percentage next to it saying how high the confidence rating that thinks that that's a possum over anything else. So at the moment, it's hovering about a 97% detection rate that that's a possum and nothing else. And as we move around, any little detection, so we're looking at head, we're looking at leftover hot spots, we're looking at, sometimes it's wee, you can see the wee, all sorts, tracks. We're building all of that information into how a possum behaves naturally into our algorithm to determine whether that's a possum or something else. This is one example. We've done, like you saw in the other Bosrufson patterns. There's another possum running around in a forestry kind of plantation park. That's more of a native bush block. There it goes and pops back up. But we're then flying in survey type grids to capture those images and determine and quantify how many possums are actually in an area. And the area, I must say, is the area or target area is typically forestry or native bushland leading on to pasture. And so we're looking to do 100 odd hectares into the bushland and pasture to make sure that there's no contamination, because it was an Osprey product, between tuberculosis and herds. Here's another video of possums. We've used the data to detect different sizes of tracks at different heights. What we learnt out of this is that animals typically use the same tracks. Bigger tracks mean bigger animals, smaller tracks, small animals. The brighter they are, the more well they're used. So because it was a natural behaviour of what possums were doing at the time, we took that data in. So here you can see a possum running, it goes under those bushes, but if you can see that there's some lighter tracks coming off the left-hand side, it uses those tracks. And so we were looking to determine whether we could spot where the possum was going to end up if it was running, and seeing if we can just identify possum, not by actually seeing the possum itself, but by identifying hot tracks that are the right size for a possum to be running on. Obviously, if there's larger animals in that area, we won't be able to see whether it's a possum or not, but we could definitely see it if it's just small tracks. If you looked at this is how this works, is it's a bunch of still images taken from a thermal camera that you can see on display. If you look at an individual picture of this thermal, rather it being stitched into this video where it loses a bit of the quality, those lines are like bright. It's like looking at a city with its lights on at night from space. They're very bright highways. The other benefit of this system, although that we look to put it into the map that you saw before, is if you're looking through camera footage, if you've ever touched a camera, like a hunting camera or something like that you've used for detection before, and you have to go through hundreds, if not thousands of images manually, this system here would run it as a video and pick up every single detection and tell you which frame it was, and it will pull that out of that collective data and just give you what we've used to create those maps. So say it's 20 photos out of 1,000, it'll give you those 20 photos to look through, and then you can determine whether that actually was a possum or not, and that actually feeds back into the system to make it better. So once we determined that we could find things and we could quantify the problem, the next step for us was to go back to where we started and reset the problem. So using those drones to eradicate the pest animals that we found, but in the locations that they're found and not anything else. So this is just an example of a flight plan that gets put together that we then send to the drone, and then the drone flies exactly that flight plan and nothing else. So you can do all your flight planning before you even get there. And we've done enough operations to know how accurate it is in different windscapes and things like that, that this drone will fly to that exact pattern. Now, if that needs to change on the day, it can, but you can basically do your whole flight planning before you even go, know the speeds, where the bait's going to go, and then on the day you're just checking whether that was accurate or not. Here's an example on an actual island where we've put down bait, and this is the actual density map of where that bait's gone down across an island. The density of different areas on those blocks, and because it was a odd shaped block and it's not a perfect shape for the spreader, then you get overlap in different densities. But as long as it's green and there's no gaps bigger than what's prescribed, that's typically what you get as a report back from the drone. And you can get that live. So as the drone's flying along, you can see where the bait's going. With the drone that I showed you before, so the small drone that was flying up on the screen, it can carry 10 kgs per flight. If we send out a team of 3 with one of those drones, we're looking to apply a tonne a day. So with a 10 kg bucket, we're putting out 1 tonne a day, 8 hours. We get lunch, we get breaks, the whole lot. But it's the efficiency of how many times we can fly, and sometimes it's anywhere from 6 flights an hour up to 15. Yeah, and just as a basic stat, it's about 150 hectares per 8-hour day, and then you get the map. Different situations, different scenarios, so that scope could change. What we learnt though, so when we've gone through this process, right, we've done all these applications, we then as innovators reflect on what went wrong, and things do go wrong. Because we want to improve the system. Our intent is not to hold on to the tech and do it all ourselves, it's to enable others. So we go back to the drawing board, we debrief with the people that we work with, and we find out what worked, what didn't. And we've had plenty of challenges in this space. We've had drones donated into the ocean, we've had drones being taken out by birds, we've had spreader systems fail midway through an operation. We've had to go from what we had as 2 drones to 40 people on the ground doing hand baiting. So we're not saying that this is perfect, but we're at the leading edge of using this technology in a new space. And what we're really actually doing is we're identifying where this technology works on the ground in real life and where it doesn't. And if it doesn't, then how do we enable that to happen if that's something that we need to do? So with all of our challenges, not to say that we're perfect, we've identified where those challenges are. And where we initially used to work in is adjusting other people's drones to try and fit the problem. And I've done that in the past with other operations and gotten to the point where if you're on an island in the middle of nowhere, there's not a Bunnings that you can run to go and fix something. You can't go and call up the manufacturer at the time you need them to say, hey, can you change this parameter for me because it's either this or go and hand bait. So when in those types of situations, when everybody else has done their job and they're all looking at you to put the bait down with a drone, you don't want to be left there with technology that's dependent on somebody else to help out. So we ended up designing our own systems, our own drones that we know can withstand Pacific weather, hot or cold, sea breeze, rain showers, different bait types, adjust to different flight plans as you need it to be adjusted. We've been hit with it all because we've been doing it for the past 6 odd years to know what system works and what doesn't. And so what the system is down there is an example of what does work. And then once that works, we're able to then focus on what's next. So we take all those challenges on board. We don't stop as innovators. We keep going and trying to figure out what that challenge is at the right price point. Doesn't have to look flash, and that's why a lot of our stuff doesn't look flash. It doesn't have a nice cover. It doesn't look anything more than it needs to look. It does its job, and it does its job really well. Going into the impact, what we can accomplish. Now, this slide isn't my slide. This is from a customer. This is directly from Island Conservation, who does this work overseas. We're a part of the enabling team to do this with drones for them. This is their numbers. So cost reduction, business as usual. The impact for them to use drones as we do it today is 6.6 US mil, just by using drones on the islands that they currently do. It means that we can enable another 10 islands compared to what they're currently doing. And it means that we enable another 25 species, threatened species populations to be saved, the same amount of money. We have a CO2 emission reduction from helicopters to less than 85%, and specifically with our petrol engine drones as well. That's where it comes into. So when you start to look at all of those things together, lots of innovation, if you take this as being risky, it's risky, but you've got $6.6 million of risk to play with. You've got the potential to enable another 10 islands. So there's a balance of innovating and using new tech where we can, and lowering that risk barrier if the islands can enable it. This is outside of our hangar in Tauranga. The front one's a drone, the back one's manned. What's next for us? So when we look at the next steps of technology, we look at what's out there now. AI, automation of processes with the enablement of AI, increased processing speeds for data algorithms for detection. We have high communication rates, or enabling communication systems between remote locations and our couch effectively, or our desk. All of that is what we're working on next. So rather than having a standalone system where that drone might just go out and bait and it needs people, that may, in the future, the near future, not need people. That might be a station in 5 different smaller drones. That might be able to switch payloads by itself. That might go and do the detection before it goes into the application without you needing to be involved in that process unless you want to be involved. So that's where we look to next. Now we've got the systems and we can enable those systems. We look at how we can optimize those systems for use and for other people to take them on, not just us. So as I mentioned, and we talked about automation for us, what that looks like is drones flying by themselves, using base stations effectively, where you can go and put these out with small drones and they can operate by themselves, either filling up with bait, changing batteries, doing aerial surveys, without the person needing to be on site. That data then gets pushed back to the operator, wherever they might be, and effectively we scale up the automation and the amount of islands that we can do without being restricted by where we as people can be. One of the other things that we looked at is swarms. So as I mentioned, having a base station, having 5 drones rather than 1 drone is the next step. One of these other things on that side is a coding detection map, which we used and developed an algorithm for, and AI basically goes through and picks out every single coding based on a percentage, and it also picks out juveniles. So we've gone out and truthed that, and it's accurate. And it's very steep terrain. So we've just gone out with a different way that's decided we've asked AI, what's the way that we can do this, and we've built an algorithm based on that, and that goes out and detects Cody based on height rather than colour, because if you looked at that map and the images that we're looking at, the colours are very similar to everything else around it, especially the juveniles. What's next for us? We started off as a service provider company, right? And we thought, great, we could go out and do lots of services. We'll continue to do services and we'll use other people's products. But when we actually went out there and started doing this type of work, we realized, okay, well, this system doesn't work. We need to build it ourselves. That system didn't work. We need to build it ourselves. Every time we saw a fault, it was because we didn't know enough about what the system actually was that we were using. So what's next for us is we are switching from that, and we have been switching from that service model into a product type model where we only do the services for things that are like advanced. We're talking like operating in a Tahitian village, going over 2 Tahitian ridges and getting that island 3 islands over. That's the type of work that we're looking at enabling, and we'll try and fail on that, and we'll try again and then, until we succeed, so that we can start pushing the boundaries, whilst the technology that we already have to go and do that flat atoll or that area in New Zealand that's easy to access is done by drones that we've gone and proven those systems on, just so that we can unlock that technology for everybody else. Because we started off as a service company and we've been through this stage before, conservation doesn't need more service companies. Conservation needs communities enabled to take on the technology. And the community is going to be there. With my team of 9, when we sit and we go and do these different types of islands, we leave. There's, in some instances, 200 islands in some of these areas that still need to be done. We were just the point of the catalyst to say it can be done. But we can't, and conservation can't afford to keep us being there because we're probably the highest cost of the operation. So the key aspect of this is not to have more service providers. I'm not advocating for that. I've lived and breathed that. I wish, that was the case from a business model perspective, but it's not. I've lived it. We need to go through, advocate that this is possible in different communities, show them how to use this technology, keep working on, from an innovator's perspective, what's next, and teach the communities to take these projects on themselves, enable them with the technology, and that way we can enable more conservation. This type of technology is cheap. The people are expensive, but the people care. And so if you leave the technology with people that truly care, that's where we start to see the change. And that's what we've done in every single island that we've been involved in, is we've found out that this isn't just a project for them. This is their life. We've gone to different islands where the community are leaving, and there's 3 or 4 people left on that island because it's covered in rats. And with rats typically comes mosquitoes, and it's covered in mosquitoes as well. We've gone to islands where not to say that we've eradicated the mosquitoes too, but we've gone to islands where there was a lot of mosquitoes when we started, we eradicated the rats, and there weren't a lot of mosquitoes when we left. When we look at enabling communities, we need to start thinking about, how do we train them? What does that look like? How do we sustain them? What does that look like in terms of higher education for them to take on their own innovation? And we look at how do we fund them in sustainable models around what they can do and what they're already doing to create a financial model that supports them going forward. So they're not at the will of, what island looks best next in terms of marketing to get that next fund. So even though we do this as a business, that's kind of the scope that we look at, is how do we enable more people? What are the barriers for them to adopt this technology and for it to be democratized so that we're not the only ones holding onto the tools? We can get this out and they can be their own service providers, because that's what they really want. Too many times we've gone to different locations and everybody's kind of just waiting on us to do our job, knowing that there's plenty more islands out there that they can do. So that's kind of my goal, is to see that this technology is put into the hands of communities, because that's where the true change is going to come in terms of scale. What happens when we get it right? So here's one example. We've done 27 islands in different regions around the world so far. When we get it right, this is what it looks like. This is an example in Kamaka, from Kamaka Island in French Polynesia. This island was eradicated before with, there was an attempt to eradicate on this island using a helicopter. I think because of the cliff face and the bait that was dropped on it, it was unsuccessful. Anyway, we came back through some years later. We used the drone on the island, and it is the first time after 100 years that an endangered animal has been nested on that island. That's what success looks like. There's plenty of other success stories around the world where we've gone through and done this, where success looks like having food that's not tainted by rats, or having disease that's no longer present because there aren't any rats. Every little story that we've been on and the journey that we've been on is truly more about the people than it is about the rats. It's about what happens next. And that's what we've been able to see and enable, is that after the 2 weeks when we turn up and we drop the bait the very first time, there's 2 times that we do it. After the very first 2 weeks, you start looking around an area where you arrived and there's rats running all over you, to no rats. And in 2 weeks' time, people that have lived with that for like 3 generations or more, starting to see that their island no longer has rats after 2 weeks. That's like transformable. That transforms the way that people start to think about what next. The big problem about rats they've lived with for their entire lives is now gone after 2 weeks. And what happens next? What do they get to focus on? Sometimes it's been organic farming. Sometimes it's been other different models where they get to bring back animals that they haven't seen for 3 or 4 generations. Or this turns up after 100 years of not being there. And on a bigger scale, if we look at using, as I mentioned, a 10 kg drone that can service anywhere from a 50 hectare site to a 400 hectare, let's say a 400 hectare site. So 50 hectares and 400 hectares with a 10 kg drone. If you look around the world, there is 7,000 islands that fit into that scope. So if I thought, hey, look, this is going to be a great job for me to get into, it is, but it's not for me just to do by myself and our team. This is why we look at communities to enable them, because we can't be everywhere at once. We can develop that technology that's going to help change it. And that's everything from me. There's a couple of other things, but I'll leave that. I've put that in there for the slide that we'll hand out later on if people want to look into that. But thank you very much for your time, and it's been a pleasure being able to share our story with you.
And I can see that everyone has been made familiar with the QR codes on the back of those seats because there's some amazing questions already. The first question that we are going to give you today is from Hannah Crichton. I'll just have a wee look for it. And her question for you, she's actually got 2. So her first question is, how can we as individuals help strengthen conservation efforts by companies like Envico?
That's a very good question. What I advocate for as a business owner in this space is to get more opportunities within New Zealand that enable the use of this technology. If we look at it from a tender perspective, for example, within Department of Conservation, the biggest users of helicopters in the country, what if that tender that came out with Department of Conservation also enabled and specifically asked for the use of drones within that space, for the areas that the drone tool would be perfect for. So that's one way. The other way I think is, as people, is to continue to advocate for projects with your local MPs, because that's how we get our voice heard. And if not, grassroots opportunities, take them. There's a huge network and opportunity for people to get involved, and I think that's one of the steps.
Before we move on to the next question, I'll just remind everyone, and I'm sure you're familiar, but that QR codes for the Q&As are on the back of the seats there, and it'll take you to the live audience Q&A, so you can post questions there if you still have some. If you don't have your smartphone or any devices on you, we also have Miyuki over here, and she'll bring you the mic, or you can also, we've got our tablet here that you can use. Okay, so the next question. How have you adapted in the design of your drones to the particular conditions of the Pacific Islands that you're working in?
Yeah, well, we learned that the hard way with drones rusting and things like that as they do. It's technology being left on sand and rainy Pacific conditions. We've developed and used different types of materials which help reduce that erosion and the wear and tear on the drones. There's a whole bunch of SOPs that as an aviator, as an aviation business ourselves, we have behind us to help ensure that that doesn't happen, along with a very, very robust maintenance schedule, as aviators you probably all know about.
Awesome. Another question from Hannah here. Can you tell us what Envico's most rewarding project has been so far? That must be really hard because everything you said back then was incredible.
I think there's different levels. So from a company perspective, I think you will never beat standing right in front of somebody and saying that I've never seen this in my life. And I've heard a story about this from a specific community leader where they've heard of their grandparents collecting eggs from a specific island that we eradicated rats from, and that not being a thing for 3 generations. So now that we've eradicated rats, they're asking when can we go back onto the island to use that as a food source, and that's actually a real thing that's happened. On a personal level, having the connection from a Pacific standpoint, being able to go to these different islands and feel the connection and actually see it firsthand of our lineage, so to say, across the Pacific, and us doing very similar work just in different pockets. So it's practical to join that all together.
Very cool. Okay, so moving on, we have another question. What shifts took place with your core five branding in 2024 and what triggered those shifts?
We started off, as I said, as a service company. We did not say that we're a marketing company at all, and our first name was Environment and Conservation Technologies Limited, and we then, made it short. And if you put ECT into a search bar, it's more about electricity than it is about conservation. We then looked at, and that change, that shift. Who we are, what does it mean to be a conservation company with specific ties to Māori values and how deep they are. And we looked at many different cultural aspects that tie in to the colours scheme that we chose, with the core five flower representing a lot for us, and also the logo change as well. So we wanted to step away from just being a technology company and actually relate ourselves to the purpose that we're actually trying to achieve. Because in the big scheme of things, we're probably more involved in terms of conservation efforts and purpose than a traditional business would be, where it's transactional. We're there for the many cups of teas before and after, and we very much want to be involved in the community aspirations going forward. So that's why we see lots of different technology, not just drones, that's coming from a place of trying to really support people and hear their challenges.
Kia ora, yeah. Are there community groups in New Zealand using this technology?
Not yet. Not from having this technology themselves and being able to use it now. There are plenty of opportunities, and I think our biggest change that we're looking to have here in New Zealand particularly is a step change on our culture and our thinking. So we get very caught up in the use of helicopters, we get very caught up in the use of volunteers, very caught up in the use of the idea of using a tractor, we'll say. Where if you look at the Pacific Islands, the other islands that use this technology, they're fast adopters. They're not looking to buy the old tractor, they're looking to buy the new thing on the block, accept the risk, but understand that risk comes with impact. And that impact was shown before, just with one customer, on how much money they save and how much more species they can protect. So, yeah, it's a deep one, that one.
Yep. What are some of the difficulties when working with drone technology, and is battery life a big limitation with the current technology?
Yeah, absolutely. So drones are just the vehicles. So there's different limitations like batteries. As the technology advances and we see different things come out like hydrogen cells and different fuel cells and things like that with bigger drones, that enables more, but you get a bigger drone. It just depends on where you're operating. You might want to be taking pictures, for example, and you could use a small drone. You might want to be doing what we're doing at a bigger level, and you need bigger drones, bigger batteries. But in these early stages, everything on a drone is pretty critical. So we really rely heavily on SOPs on how we operate to make sure that that's not a high risk.
Awesome. Are there scenarios where a helicopter would be more effective than using a drone?
Absolutely. And we're not advocates to say use a drone over everything else. We're a helicopter's a tool, and we're also a tool. And we're just the tool that hasn't been used before, and we're identifying where those areas of use are and where they're not.
Long term, would you have to do maintenance of the islands that have reached eradication when rats potentially come back to the island?
Yeah, for sure. So this isn't an isolated project where we go through and do the eradication with bait using drones just by itself. There's an educational piece that starts long before this program. There's the buying of the communities, there's the teaching at schools, the whole lot before that's an accepted project, before we come through and do the eradication phase. After the eradication phase, it's all about protecting what you've just gained. So biosecurity measures in ports or points of entry where there's a potential high risk of reinvasion. So that's why we looked as a company to get into long life pest eradication pest traps as well, to help that next step once we've left there, to help that biosecurity process happen.
Awesome. And I really like this question. Does the observer effect influence animal behaviour? In physics, the observer effect refers to the disturbance of a system caused by observation.
Yeah, it's a hard one to answer. If they take it into two parts, you read the first part again.
Yep, so does the observer effect influence animal behaviour?
It does, but it is why we've developed technology. Well, we're aiming to adopt technology and innovate technology that doesn't disturb or limits the interaction with those specific animals, allows them to be natural in their own habitat, act how they would be normal behaviour without trying to change them or make them learn something to do what we want. Because we've seen what that does, and it's a 30% detection rate if you use traditional methods. So we've tried alternatives to try and change it.
Awesome. So what is the image processing engine you use for detection? Who asked that question?
We developed, so we used the stock standard online to do the very first model. We've ran 7 different models so far, and it's still running different models to try and increase the percentage. But we, with our engineers in-house, ran our own, so to say. But we did start with a public model straight off the shelf that's available for free. And I think now that we've got more access to AI, it's even better. So I wouldn't say that one is yet better than the other. It's just time and library, I think, is the better question the better answer to give you, is getting a good library behind you.
How did you get into this work, Cameron? And were you always an innovator? Was there a specific innovator who inspired you?
Oh, that's a good question. I got into this work before Envico. I used to fly drones for another company doing all sorts of different types of research using Yamaha's remote control helicopters here in Australia, Japan, and our goal, we're operating as operators, was to go out and prove different markets on where this drone worked and where it didn't. So from a very early outset, we were trained to fly drones in the early days of when drones actually, I think the very first Phantom camera drone came out when I started flying drones. So like it was early stages for normal drones as well when I was flying them commercial. That's how I built the skill set up, but it wasn't until I started Envico where the skill matched passion. Like I found what I was passionate about, and it was conservation. I'd never had that before. I never had that exposure before. And I was able to utilise a skill that I thought wasn't really applicable in those days of early drone use to anything except what I met conservation, and I saw the impactful change it made in like 2 weeks, and I was like, this is where I'm going to live forever.
Oh, cool.
Yeah, so in terms of an innovator, no, but I think inspiration is just drawn from impact.
Cool. We've got about 7 questions to quickly work through as well. Everyone's as interested in me as me. So in addition to possums, what other species can you detect?
So we've gone right down to, and others have as well, mice. So after mice eradications on islands, they've gone through and used thermal detection algorithms on mice and have had very good success on that. Possums, cats, ducks, hedgehogs, deer. I think that's what we've got so far. Wallabies would be next.
Awesome. The next one's not a question but a message. We have aerial mapping tools from another era in this whare. It's been so relevant to hear this kaupapa i tēnei pō ngā mihi nui. That was the message. So tēnā koe mō tō karere te reo. Are there any community groups in New Zealand using this technology? Did I already ask that question? Yeah, I did, didn't I?
Yeah,
Sorry.
Yeah, and there's lots of different community groups using the technology as a service, but we really want to see them being enabled to take on the technology themselves.
This is a good question too. Have you worked with any specific iwi regarding pest eradication?
No, but we are building programs for this to be enabled by themselves. So rather than us do the application, my goal is education now and providing the technology. So having innovators inside of our workshop from specific iwi and teaching them how to build, maintain and operate these types of aircraft and then taking it back.
Very, very cool. How would Envico relate to biological control of pests in the Pacific Islands?
So we initially started off doing just the eradication phase, but we've looked at it from a holistic perspective. So we're giving people the opportunity to quantify what their problem is, push the reset button if they're at that phase, then protect their gains by putting out pest control devices. And if there's no birds around to disperse the seeds, we can't do it manually by hand or there's some limitation, disperse native seed pods. And we've done different projects of all those 4 different pillars right across the world. And so our ethos, our mandate, so as a company, is to help somebody start and finish a project and give them whatever tools they require between starting and finishing. And they don't have to start at the start, they can be right at the end phase and take on native reforestation. The next step after all of that is how do we sustain it with financial models and looking at biodiversity credits or carbon credits to fund projects that are just doing well.
Awesome. What are some of the sources of funding for the work that you do?
So, and I mean, we can't complain. Governments change, right? And there was more support, direct support, I should say, with conservation under the previous government. So that was one avenue of funding. With this change in government and the change of budgets, and some aspects I actually agree with it because it's forced people to take a different look in New Zealand of how we achieve the same impact with less money. And it really aligns with using tools like drones and automating pest devices. So there's still avenues down that channel, and other channels we've just gone for service to prove that this works in different areas all around the world. So we operate everywhere, and there's a mixed business model in that.
Awesome. Is there work going into making drones quieter?
Yes, there are, and I think people will appreciate it when they start flying around more. And the recent change, in the aviation law, there's scope for drones to be flying over people's houses without permission, lower. So, noise is always going to be a challenge. But there's great companies here in New Zealand that are doing it as well, looking at making propellers quieter. I think we'll just learn along as the journey progresses.
Awesome. And from a Te Ao Māori perspective, how does baiting fall into that? And have you had any resistance from iwi to baiting?
Yeah, so I'm tūhoi from one side, and very much anti-baiting, and for good reasons. I also have dropped a lot of bait in other areas, and I've seen the pros and I've seen the cons. And if you have I've seen islands transform in 2 weeks, and we've had conversations with people monitoring those islands 8 to 16 weeks later saying, there's a frog here that was never here, or there's trees that we never surveyed that are coming up after that short amount of time. So, there's...
Awesome.
Yeah.
We have one more question that's just snuck in. Do you feel the tools currently available for communicating drone work and results are good enough for the scale of adoption that's needed?
No. But that might be our problem. because we've just been heads down building technology and not advocating the work that we've been doing. And I'd say that that's probably a challenge for lots of different innovators. I kind of look at it as like a golden triangle, where you've got community groups as the real leaders to take on the technology and push it. You've got innovators that are looking to develop that next leading edge and enable those communities. And then you've got the funding community, you've got the funders on the other side of the triangle. I think all of those working together it shares that resource load. So if there's a marketing push where the innovators are engineers and not so strong as advocating, they're putting all the effort into the tool, from a funding perspective, they really want to advocate that, because it means more exposure, more opportunities for that triangle to exist. So I think it's not so much it's our fault thing, but it's also an opportunity for others to take on if we all work together.
Well, we have one question over here.
Do we just?
Yep, you're doing great. Go for it.
Last night on TV, they had drones being used for motorway control, and they were remote drones. So, like you're saying, someone's sitting in their office, and the drones had this little garage that just opened up, and the drone flew to the hotspot, and presumably, hundreds of k's between the two operators. I just wondered, how does the security operate around that? So if you've got a drone that you say you're going to be on your couch and you're nowhere near it and you've got some kind of protection around it, how do you run that security around it that someone's not going to come in and tamper with it?
I think the first thing is always trust, and to do something about it after the incident happens. We've looked at doing different stations in agricultural fields, for example, with the same problem, and in some aspects we've had to put them in gated areas, but only if there's a problem, really. You don't want to. There's a good example I had when I was doing drones a long time ago, where we were spraying right next to a motorway, and the council said put out cones, but we were with the CAA, and one of the regulators was out with us, and he said, actually, don't put out cones, because then people are going to look. So sometimes putting out more security is going to draw attention more than it is going to pull apart. But I say if nothing's happening, then probably you don't have to do anything, but trust model first. Yeah, good question.
Well, I think that wraps up tonight's kōrero. So thank you so much for being here. Tēnā koe for your time and your mātauranga this evening. It's been incredible having you here as a guest tonight. And Cameron will be available a little bit longer if you'd like to speak with him. I'm sure there's a few people that would. The Aviation Hall and Bar will remain open until 9 p.m. if you wish to check out our collection while you're here. We've also got our volunteer aviation host here. Is that you over there? Rick? Give him a wave. He'll be happy to speak to you about our beautiful collection here tonight. But other than that, should you have any other questions, we've got team all around to help you. And thank you so much for coming this evening. Thank you again. Mā te wā.
Thank you.